Okay, we'll see what is electric field intensity E and also flux density, but by using which law is by using Gauss law. Okay, and it is for spherical surface of radius r. So for this, we will use this sphere of center point here. Okay, so the radius for this first one is r1 and this outer circle is r2, and this surface of sphere which is having a uniform charge distributions, and the distance is a. Okay, so we'll consider three cases here. One is r greater than a. So this is a. R greater than a means this portion, then r equals to a, and then r less than a. So here first case we'll see E outside the sphere. So this is a sphere. Outside the sphere is r greater than a. So the total flux is surface integral of d dot ds equal to q enclosed. Use the Gauss law. So here sphere is considered. That's why the point is r theta phi. For differential elements, r dr theta ge r d theta phi ge r sin theta d phi. So now we should write this d and ds. So here we can write capital D vector, that is electric flux density, as dr and ar. Similarly, we can write ds, which is normal to the radial r direction, can be written as leaving r for theta, write r d theta, and for phi r sin theta d phi. So multiply this, so you will get r square sin theta d theta d phi in the unit direction ar. So now the side total is equals to closed surface integral of d stand for dr ar dot r square sin theta d theta d phi ar. So now do what you can do. See what you can do the modification here. So ar dot ar is there, so that value is going to be 1. So after that, this dr I will take out. Surface integral, we can write two integrations. One integration for sine theta d theta we can write, other integration for d phi we can write, and this ar dot ar is 1. Okay, so this r square also you can take it out. So these are the things, but here for theta the values are 0 to pi. For phi the value is 0 to 2 pi. So it is r square dr. So find out the value of this. So we know that integration of sine theta is minus cos theta. The limits are 0 to pi, and here it is phi. The limits are 0 to pi, so it is 2 pi. Okay, find out what is this r square dr and 2 pi keep as it is. So here this value minus of cos minus 5 plus 1. So here minus of minus cos 0 is plus 1, so it is 2. So the overall psi value, which is equal to r square 4 pi dr. This is nothing but charge q. So dr can be written as q divided by 4 pi r square. Okay, so if we write in terms of the flux density d, so it is going to be q divided by 4 pi r square into ar, coulomb per meter square. Okay, so this is what you got E. Similarly, based on this line we can write this E is nothing but d divided by epsilon. So we are going to get this what is it, epsilon r square ar. This is E, and the unit is volt per meter. You can observe this d and this E. Okay, this is electric field intensity due to the sphere of radius r. And here we can consider the next part. The next part is this E is equals to Q divided by 4 pi epsilon r square AR. This Q we will consider with respect to the volume charge. Okay, so here this is rho v dv. So dv, what is dv stands for? That point we should take. Okay, so that point is r theta phi for r dr r d theta and r sin theta d phi. So multiply this, you will get r square sin theta d theta d phi. So multiply all, so it is r square dr sin theta d theta d phi. Okay, so here you can write this q as volume integration 3 times r square dr sin theta d theta d phi. So one integration, do it for r square dr. So here the r value is 0 to a. So we'll consider the case number 1 when r is greater than a. So we'll consider this case. So similarly do it for theta. So it is sin theta d theta. Similarly do it for phi. Okay, so here the integration of r square is r cube by 3, 0 to a. Here the integration of sin theta d theta, we know that minus cos theta, 0 to pi. Here the integration of this is phi and it is 0 to 2 pi. So we know that this can be written as a cube by 3, upper limits minus lower limits are 0. So next you can consider this as minus cos pi, so it is going to be plus 1, minus of minus cos 0 plus 1, so it is 2. So here it is 2 pi. So total 4 pi a cube by 3 you will get. This is q. This you can substitute this in this electric field intensity. Q stands for 4 pi a cube by 3 divided by 4 pi epsilon r square into ar. Okay, so this one you can 4 pi will get cancelled. Okay, so you can write this as a cube by 3 epsilon r square ar is electric field intensity when the case is r greater than 0. Okay, so case 2 is when r is equals to, sorry, r is greater than a, and you can see r equals to a. R equals to a as e is equals to. So now what you can do is you can just substitute here a as r. So you will get r cube. So r square and r cube will get cancelled. So he'll end up with or you can write here r is nothing but a. So it is, you will get r divided by 3 epsilon into ar. You will get when r is equals to a. Okay, so r you can write this as a divided by 3 epsilon ar when r is equals to a. This is volt per meter. Okay, so similarly you can consider the case number 3 when case number 3 is r less than a. So r less than a is entire process is same. So here what is the process is this process, entire process is same. You will get d value is like this. Okay, so and also you know what is ds. Okay, so d value is we know that q divided by 4 pi r square ar. If I consider ds is again r square sin theta d theta d phi you will get. So take and do this here the volume integration here the volume integration for the case number 1, 0 to a we have considered. So in this case, so here we should consider this as r only, because it is r less than a is there. You can observe this diagram. R less than a is nothing but r only. So here this, instead of a, becomes r. Okay, so it is going to be r only up to the last point. So once you will get r here in this equation r, so it is r cube and r square, so you will end up with r. So that is the only one difference you'll be having. So you will get this as the third case. Okay, by considering the sphere. So first case, when r is greater than 0, this one, when r is equals to, when r is greater than a, it is not 0, a. This one, when r is equals to a, this one, when r is less than a, this one. Okay, so if you understood this diagram very carefully, r greater than a, this part, r less than a, this part, r greater than a, take 0 to a in this r volume integral, and when r less than a, take that q is equals to the triple integral r equals to 0 to r only you should take. The rest is same, 0 to pi, and phi is 0 to 2 pi. If you take and if you do this dr dsr, you will get the same, and only the thing is this difference. Okay, so this is the electric field E, and also if you know E, you can write what is D. Okay, D vector by using this. So this is the heading, electric field intensity E and D for the spherical sphere, but using what type of law? Gauss law. Okay, so we have used the Gauss law in each case. So that is why here we can write this derivation. Thank you. We'll see in the next video about the next update. Do subscribe my channel for the latest notifications and updates. Thank you for listening. We'll see you in the next video.